Chapter 8, Exercise 8.97. Hot water often contains dissolved calcium 2+ and magnesium 2+ ions. One way to soften water is to add phosphates. The phosphate ion forms insoluble precipitates with calcium 2+ and magnesium 2+, removing them from solution. A solution is 0.05 molar in calcium and 0.095 molar in magnesium. What mass of sodium phosphate would have to be added to 1.0 liter of this solution to completely eliminate the hot water ions? Assume a complete reaction. So first, phosphate is PO4 with 3 negative charges. So sodium phosphate is sodium 3 PO4. Now let's look at the reaction between calcium 2+ and phosphate. Because phosphate bears 3- charges, 3 calcium 2+ react with 2 phosphate ions. Same here. So we have a ratio of 3 to 2. Number of moles of calcium 2+ and magnesium 2+. Alright? Versus the number of moles of Na3PO4. This should be 3 to 2. Alright, that's the idea. Now what's the number of moles of calcium 2+ and magnesium 2+? We have the volume and the concentration. So we can easily add up the number of moles of calcium 2+ and magnesium 2+. So over here we have 0.05, that's calcium. 0.095, that's magnesium. Alright, and then times 1, because we have 1 liter here. This is the number of moles of calcium 2+ and magnesium 2+ combined. The number of moles of sodium phosphate, well, we don't know. Let's say the mass is M. I'm going to use M as the variable, divided by the molar mass of sodium phosphate. Sodium has a molar mass of 23. And we have 3 sodium in the formula. And plus PO4. Phosphorus is 31. Oxygen is 16. And in PO4, we have 4 oxygen. So this is the equation that we need to solve. Alright, obviously you can just solve this with a calculator. But using Wolfram Alpha, it's more convenient. We get 16 grams. Now let's get back to the equation. Again, we have a ratio here. Alright, this is calcium and magnesium combined. We can combine this two because they both bear a 2+ charge. And over here, this is the number of moles of phosphate. We have the mass of the phosphate, sodium phosphate. We have the molar mass of sodium phosphate right here. What if you use potassium phosphate? And then this 23 has to be replaced with 39 as the molar mass of potassium. And then you need a larger mass if you use potassium phosphate. 3 to 2, again, it's just because 3 moles of calcium 2 plus react with 2 moles of phosphate. 3 moles of magnesium 2 plus react with 2 moles of phosphate. So this is how we set up this equation. Alright, also with a calculator you can tell this is just 1.5, and the mass divided by all this should be this sum divided by 1.5. Alright, and this divided by 1.5 multiplied by the molar mass of sodium phosphate, you will get the value of M, which is the value of the mass of sodium phosphate, 15.85 grams.